Good afternoon, folks. I'm back. I'm Joe Weiss. I'm a gastroenterologist physician. Gave the earlier program, and I wish I had more time for that one, but there is limited time for this one, so we're going to go right into it. This one is called The Quest for Immortality and Vitality. And what I'd like to share with you, and the odds are very, very high, that you will be living a lot longer than you think, particularly if you're young and healthy. Lifespan will continue to grow, and it has been growing for the last 100 or so years. A lot of that is due to reduced infant mortality. That is, people still live to about 70, 80, 90, 100, up to 120, and that was considered the extent. But the science of longevity and the potential of immortality is advancing very, very quickly. So let me just share with you, there are other disciplines which have advanced very quickly. Top two slides. From the first airplane flight at Kitty Hawk to supersonic transport took less than 70 years. That's pretty amazing progress. The lower one, the first solid fuel rocket to landing on the moon and returning a man to Earth, again, about 50 years or so. Pretty amazing progress. Taking a look at the microbiome and genomics, the advances are staggering, even faster than these experiences with the astro-aeronautical theme. Speaking of astro-aeronautical theme, I feel sorry for the birds who are saying that they're getting freaked out by the wireless technology. Now, I do want to share with you that lifespan is variable, and there are species on this planet, and if we just go with the rodents alone, the range of lifespan is pretty dramatic, from just a few months to many, many years. The bottom right is the naked mole rat. I thought you'd want a closer view of that one. This is what he looks like. This is an X-rated program, is that what this is? The naked mole rat is actually an amazing animal. It lives about 28 to 30 years, does not get cancer, and is being used in longevity research. So it's a very attractive life form to deal with. But I do want to share with you that when you start as a single cell, and we all started as a single cell, now you've heard the term exponential a couple times this morning, exponential growth. I want to make sure you really understand what exponential growth means. We start off as a single fertilized cell. The cell divides in two. Those cells divide in two. Those cells divide in two. If I were to offer you $1 million cash right now, how many people would take it? You don't want $1 million cash? Okay. How many would rather have 1 penny and have that penny double each day for a month? Okay, those who really know will go for the penny because they know the power of exponential growth. That 1 penny, if you double it after the first week, it's about $1.27. After the second week, it's about $10. After the third week, it's about $200. After the fourth week, it's $1 million. And after 30 days, you have $10 million. That is the power of exponential growth. So we start off as a single cell. The cell divides, multiplies. If it continued indefinitely, by the time the 9 months of pregnancy were over, the poor mom would be carrying around an elephant weighing several tons. So the cell division has to stop, but it continues in cancer cells and it continues in stem cells. So you can move very, very quickly, but you can also age. So you start off as a single cell. As an adult, you're talking about 37.2 trillion cells is the latest estimate of how many cells an adult human has. So you've gone from a single cell to trillions. And then we age. And again, lifespan, longevity, has gone up in a fairly linear phase over the years. But something striking is happening. Something striking is happening, and this is just going back. Remember the blue zones? That was the state of longevity research a number of years ago. You look for areas where people lived long and see what they did in common. So Loma Linda University area, a lot of Seventh-day Adventists. Vegetarianism is found to be associated with longevity. Those who are in Okinawa, Japan, have turmeric, which is curcumin, which basically has a COX-1 inhibition. It's an anti-inflammatory. That's helpful. Sardinia, the Mediterranean diet, the polyphenol wines, the fava beans. A lot of these things are common sense, and we recognize, okay, these are associated with longevity. We're probably well off to imitate and try to follow a lot of these, which does make sense. But also realize that there is a danger to living on planet Earth, and a lot of it has to do with external environmental concerns, and this leads to damage to the mitochondria, it leads to damage of the DNA, and a number of it has to do with tobacco, ultraviolet light radiation, solar radiation, pollution, inflammation. Inflammation is a very big one that all play a role in the aging process. Inflammation is associated with a whole host of disorders, and some you've heard about this morning already. But I do want to share with you that inflammation appears to be one of the main keys in aging. So if you could reduce inflammation, you may be able to slow down the aging process. There's another factor involved. You heard the term epigenetics. Epigenetics is a fancy way of saying something outside of the gene. Now, we all have genes. Humans have about 23,000 genes. As I mentioned to you in the earlier program, genes are critically important. They describe the design of proteins, and the proteins have functions from neurotransmitters to hormones to every single enzymatic function a cell has, all of cellular metabolism, all directed by genes. The genes are present in humans, 23,000. They're present in every single life form. We share a lot of these genes with all sorts of other animals and plants and microbes. Epigenetics is something important. It basically says that genes by themselves are not your destiny. You may have genes, you may have inherited genes, but epigenetics can turn the genes on and off. It can modify the genes. So epigenetics can be environmental. It could be temperature, radiation, food, drugs, nutrients, probiotics, microbiome, you name it, it can affect the epigenetics. I think the best example of epigenetic phenomenon is a caterpillar. A caterpillar is identical to a butterfly in the DNA, in the genes. It's the same organism, but it's the epigenetic changes that change it from a caterpillar larva to a butterfly with wings flying. And that is the same genomics, the exact same genes. That's just epigenetics at work. And epigenetics are at work everywhere. Your genes are not your destiny. Epigenetics plays a major role. And going back to the microbiome plays a major role in epigenetics. We were talking earlier, I wish there were time for more questions about the diet and the importance of the diet. The diet changes the microbiome. The diet also contains chemicals, metabolites, genes, products, hallucinogens, stimulants, you name it, they're present in the food. So we're talking about a couple of products that might induce hallucinogenic phenomenon that can become habit-forming and addicting. Every product that you consume in your diet has some form of biological activity. And again, a lot of the genes are shared, so your diet is much more important in your health and wellness than you might think. In fact, it goes back about 2,000 years ago. If you follow what Hippocrates said 2,000 years ago, his words of wisdom are true today as well. He said, let your foods be your medicine, and your medicine should be your foods, because food actually is medicine, and it does impact not only the microbiome, but the brain directly, your whole body, your whole physiology directly. You heard about telomeres earlier. That's just one aspect where we recognize that it's a marker for longevity, and the shorter the telomeres become, the shorter the lifespan of the cell. You can think of the telomeres as the caplet of a shoelace. Without that caplet, without the telomeres, the chromosomes can disintegrate, fall apart, the cell will no longer live. With the preservation of the telomeres, you can preserve the shoelace, you can preserve, hopefully, your lifespan longer. Genetics is fascinating and sometimes frightening. There is an illness called progeria, you may have heard of. It is a terrible disease for those who have it, but it may also be beneficial for those who do not, because it is pioneering in terms of understanding the role of genes in aging. Progeria, the victims of progeria, age rapidly. They age dramatically. Someone has speeded up their biological clock. So by the time they're 10, they're the equivalent of being in their 80s or 90s. By the time they're 12 or 15, they're usually no longer with us. It's a terrible disease, but again, it's uncovering a lot of the mystery of the genetic influence on aging. There's other condition, which is the exact opposite, where people have a genetic disorder where they do not age, or their aging is very, very slow. Found in South America, it's a remarkable small population, but they can be in their 30s and they look like they're 10 years old. Biologically, they look like they're 10 years old. And as I mentioned earlier, there was a roundworm Caenorhabditis elegans that Sidney Brenner worked on at the Salk Institute. That one gene, manipulation of one single gene, can influence lifespan tenfold. So the importance of genomics, genetics, epigenetics in longevity is just beginning to be uncovered. Now, I like the headline which suggests that the medical advances are advancing for the mice, not necessarily for humans. Mice are used in genetic research and biological research. There is a tremendous overlap. It's about 92% of the genes are identical between a mouse and a human. So they are a model, and a lot of the scientific data developed in mice is extrapolated to humans. So it's fascinating research work. By the way, I also want to share there are so many approaches to longevity that even if only one of them panned out, you can expect significant enhancement to lifespan over the years and decades to come. So you have epigenetics, you have the microbiome, you have stem cells. Stem cell transplants have been around for about 50 years. You may not recognize it, but bone marrow transplants are basically stem cell transplants. They've been around for 50 years. Stem cell transplantation does work, and it's working in more areas than most people are aware of. Stem cells can regenerate any cell in the body. It's the original cell. It's much like the first cell of your body when the egg was fertilized, becomes every cell of your body 100 trillion cells later. A stem cell can be directed, and the science has advanced to where they can direct the stem cell to become very specific tissue, and using scaffolding of an inert material, you can grow biological organs. Strange as it may sound, they have already been grown and transplanted successfully. Stem cell artificial trachea have been transplanted. Not to become too sexist about it, but artificial sexual organs for women have been transplanted. They're working on transplanting hearts and other organs as well, generated from stem cells. The science is advancing rapidly. Remember, there was a great controversy because a lot of the stem cells were derived from fertilized embryos that were to be aborted. So there was a great hue and cry about it would help to promote abortions. That's not what happened. And the good news for the science is that it has gone well beyond the fertilized embryos that are required. You can actually take mature adult cells, regress them back to stem cells, redirect them to a completely different tissue. So the technology is evolving very rapidly, and the science is exciting. Well, besides stem cells, what about bioengineering? What about artificial organs, artificial limbs, artificial eyes, artificial hearts? You know, so many people die of a heart attack or cardiac failure. Well, you can grow a new heart with stem cells. That sounds attractive, but what if you happen to have a battery-operated replacement heart, perhaps one that was nuclear powered, that will keep you going for another couple of hundred years? That technology is coming along very, very rapidly. So much so that technology is actually superseding the human physical capabilities to where it actually has reached Olympic sport level. Do you know those running blades that are available for people who have prosthetic limbs? They're illegal in the Olympics because the people with the running blades can run faster than people with natural feet. So again, we're talking about technology and biotechnology advancing so rapidly. Another concept, again, will be playing a role in longevity, is called nanotechnology. Nano is extremely small. Nanotechnology, do you guys remember a movie from, must be about 60 years ago, or 50 years ago, Fantastic Voyage? This is the same idea. I don't know if they've remade that movie, but it's coming. Fantastic Voyage is coming to our real lives very soon, where you're going to have technology that can travel through the body, through the bloodstream, to various tissue, and manipulate and modify it. It's also going to come about with using viral transfer of genes. You're going to have gene transfers, genomic transfers. Now, you may think it's all science fiction. Let me throw this one at you. Did you know that there is a gene in the firefly that causes illumination? causes the firefly tail to glow in the dark. The fellow who did this work, Arjun Chen, got the Nobel Prize for his work on the luminescent gene. They're actually able to transplant it into other organs, other tissue, and they actually transplanted it into a cat. There is a cat that glows green in the dark. So this is a gene that's been transferred. They actually have transferred it to tobacco plants. You can see the plants growing in the dark. Science fiction or horror, it's kind of hard to decide which way, but because of the great overlap in genes and the ability of genes being the universal language, to go from one organism to another is opening up either a new horizon or a Pandora's box, depending on how you want to look at it. Another way to enhance longevity, you probably heard about it, wasn't displayed today at lunch, was caloric restriction. And if you had the dinner plate on the right served to you, you may think you're living much longer, or it may just be that the years are being stretched out because you're suffering from all the caloric restriction. But they're finding now that there are ways to basically reproduce caloric restriction in pill form. You're able to use a metabolite to give you the same biological benefit of slower aging by taking it in a form like that. Antioxidant foods are becoming more popular. Again, oxidation, inflammation, metabolism. I like this cartoon. What fits your busy schedule better? Exercising 1 hour a day or being dead 24 hours a day? Now, you've heard a lot about exercise today, and exercise is important. And if you were to pick and choose one part of this talk, the most important part, exercise, is also associated with longevity. So by all means, do it. Again, fantastic voyage in my field, gastroenterology. I do want to save lives today. I want to warn those who are not aware, if you're age 50 or over, you should get screened for colon cancer. Tragically, it is a devastating disease, but it is identifiable early, curable early, particularly if there's any family history of inflammatory bowel disease or colorectal cancer or colon polyps. And one of the new diagnostic approaches is not the garden hose colonoscopy, it's swallowing a small capsule. The image is much enlarged. It's the size of a horse pill. You swallow it, it takes pictures all the way through your digestive tract. Interesting home movies, but it's another alternative. There's also a new FDA-approved using genomics DNA test. You provide a wonderful fecal sample. You don't tell the mailman what you're putting in the mail. You mail it off, and they analyze for markers for genes for colon cancer and colon polyps. Oops, let me skip over that. Another approach to longevity is freezing, cryopreservation. You probably have heard all about the Ted Williams fiasco, whether his brain is frozen in Arizona and it'll be resuscitated in the future or not. Strange as it may sound, there is a rationale to the science behind cryopreservation. I do not advocate it. I don't believe it's going to be a very useful methodology. What happens when you get thawed out? Is the technology going to be there? Or if you do wake up in a couple hundred years, what are you going to be thinking about? But there is a rationale for it. But I do want to share with you one important approach to longevity. I want to make sure that you enhance your lifespans now, is the advance of personalized medicine. Medicine is population-based. That is, you are treated with one pill that works for a lot of people, but it's not one size fits all. It's basically personalized and should be personalized. So when you're looking at your own therapy using genomics, you will find that the years to come, personalized medicine will be much more designer-driven. Now, and again, drugs do have side effects. Every once in a while, it'd be nice to have a side effect which are attractive. I do want to share just 2 slides, tips for a long, healthy life. Basically, this is going back to ancient philosophy time. There are no brilliant words of wisdom here, just all common sense. But one other common sense thing I would like to leave you with, as I'll show you the second slide, is the world is more dangerous than you might think. And if I may have the bully pulpit for about 60 seconds to share with you and hopefully protect your lives, you need an advocate protecting you if you get hospitalized. If you're in a hospital, you need someone watching over you, protecting you. As much as I'm proud of medicine, it has a terrible track record in hospitals. Do you know what the death rate is in the United States in hospital accidental deaths each year? 440,000 deaths each year in American hospitals by accidents, by medical errors. A lot of it is drug reaction, drug interaction, and we're talking earlier about the microbiome, and I suggested be careful about probiotics because you don't really know what they're going to do. There are millions of them out there, and each microbe produces thousands of proteins, each one of which has a biological effect. We don't know what they're going to do. We do know the drugs are out there and they interact and they cause side effects, but there is no central database. Nobody is collecting the data. Nobody is putting together a computer software program to identify which drugs are killing people in which combinations. So Deepak Chopra, myself, Nancy, and others have started an op-ed piece, and we're trying to promote the idea of being an advocate for your own wellness, encouraging the government to be more promoting preventive medicine, integrative medicine, public health, safety first. Be careful out there, have a long, wonderful life, but just because you have a long, wonderful life and a lifespan that may go out to 1,000 years doesn't mean you're not going to be killed off by your well-meaning doctor when you're hospitalized for pneumonia.
I wouldn't stop you, but we got to ask you Thank you so much. Joe, great speaker, Joe. We're glad we had you give a couple of talks. That's fantastic information. I have the great pleasure now of introducing someone who I met. She probably doesn't even remember how long ago we met. We met at a biotech conference. She and her dad were there in Palm Springs. I think it was 2004. She's a founder of the Webby Awards, Emmy nominated, and the State Department has her go around the world and represent the United States as a filmmaker. I hope you'll welcome to the stage a warm Aspen welcome for Tiffany Shlain.
I'm so happy to be here. I'm a Henry Crown Fellow at the Aspen Institute, so I get to come once a year and be in paradise and talk about ideas. So this is like my favorite thing to do. So I am going to talk about a very small subject today. Oopsie, the future of our species. That's what I'm going to talk about in 15 minutes. And I'm just going to cram it all in. But I think my interest in the brain started when I was in fourth grade, and my father, who's a surgeon, brought a brain in a bucket to my class. And he had this bucket and taught us all about the brain, and then at the end of the class, he lifted up the lid, and there was like a brain in formaldehyde, which made most of the kids screamed and ran out, and I was fascinated. He was also, I should say his name. His name's Leonard Shlain. And he was a surgeon and inventor, and he wrote best-selling books about the connections between art and science, the connection between literacy and patriarchy, and human evolution of our species. So that was my father, and my mother was studying to get her PhD in psychology my whole growing up. She was a working mom, so it took her a while. So basically, we were talking about the brain and the mind my whole upbringing, and it absolutely shaped my life's work. I make a lot of films about, nothing gets me more excited than taking a really complicated idea in science and figuring out how to visualize it. Like during all the talks today, I was just like, oh gosh, I need to make an animation of that. And getting this incredible science out far and wide into the world is incredibly exciting. And actually, this film was called Brain Power that I made, and it was about the neuroscience of the importance of the first 5 years of life, which we've talked about a lot today, and it was shown here. And I also recently made a film called The Science of Character. I'm really interested in, this is based on the positive psychology movement, and we premiered the film and had something called Character Day last year. And Character Day is happening again in September, and I'll be premiering one of my new films, The Adaptable Mind, which looks at, through neuroscience, what are the skills you need to flourish in the 21st century? How do you keep your brain really adaptable and supple to continue to adapt and thrive in this world? So there's information about that. I just want to kind of share those films because it's very pertinent to this audience. And I was working on a film about 7 or 8 years ago called Connected, and it looked at the history of the brain's evolution. It looked at the history of connectedness from the Big Bang to the Industrial Revolution to today and to our future. And I was working on the film with my writers. I have a film studio in San Francisco, and I was like, Dad, write this film with us. It'll be so much fun. And it was the first time we'd ever collaborated on a project. So we were having a great time going deep and wide into civilization. And then he, one morning, couldn't button his shirt, and he was rushed to the hospital and diagnosed with brain cancer, of all things, for my dad. And he was given 9 months to live. and we were incredibly close. I'm actually wearing his hat in his honor today. But to be with him, and we were so close that we talked about everything. He talked about what was going on in his brain. We said everything we wanted to say, and he was also fascinated with how it was changing his brain. And I should say the whole time, for about 10 years or before he had got sick, he was working on his last book about Leonardo da Vinci. And he believed that Da Vinci was a glimpse into the future of our species. And he felt like Da Vinci was a culmination of all of his books, because he wrote this seminal book in the 80s called Art and Physics, Parallel Visions in Space, Time, and Light. And the book looked at how artists and physicists were talking about the same ideas through different languages. And he felt like Da Vinci was the only human in history that was able to intersect art and science and master it so completely, and that he had such a great skill of cross-disciplinary thinking in his own mind. He came up with the most ideas of any human in history, and he believed that this cross-disciplinary thinking gave him a higher level of consciousness. So the last 9 months of his life, he would either spend time with family or friends. He usually only had about a good hour a day, or he would work on that book because he was on the last chapter. And he finished the book and days later passed away. And I mean, literally days. And so then you have to understand, it was an over 500-page unedited manuscript. And he normally would spend a lot of time with his editor. That was his favorite part, was editing the book down and carving it out. And so he wasn't there, and so my brother and sister and I were like, oh my gosh, what do we do? And his dying wish was, get this book out into the world to have other people develop it more. And so my brother and sister and I got an editor, we got a publisher, a New York publisher. I would work with the editor and basically try to represent my dad's ideas. So it was this amazing experience of like having a conversation with my dad in my head through his book, and trying to get to the core ideas of what he was saying, which are so relevant to today. So the book is called Leonardo's Brain. It was published last fall. And it was like my dad was doing an intellectual brain scan on Da Vinci 500 years later. He was trying to reconstruct his brain, and he had so much knowledge of the brain and in the brain's human evolution that he thought that Da Vinci could give us clues for today. He wanted to understand, and just like there's so many books about Da Vinci. I mean, it's not the first guy to write about Da Vinci. But like everybody's got a different theory. What was it that made him make so many scientific inventions and make the Mona Lisa? And he built off all these other theories of Da Vinci. And what he suggests, and his big insight, is that Da Vinci is actually an anomaly in human evolution. And not only was Da Vinci a master of art and science, he was also gay, vegan, and a pacifist. So I always thought he would do great in my hometown of San Francisco. But so my father thought Da Vinci represented the future, and think about all those things. I mean, he was a master of cross-disciplinary thinking, gay, vegan, and a pacifist, and that was the future. So my father, he points to this idea in evolutionary biology where there is occasionally a mutation in the species it's got such a variation that the genetic mutation is so extreme that it has the potential to point us where we are going to become. So it's the term sport, which is an unusual word, but it's like the third definition down, and that is, it's really to sprout off of the species. And my father really believed that Da Vinci was sprouting off of the species. So the lifespan of a higher species is between 1 and 1.2 million years. And it either becomes extinct or it evolves. So my father was asking, are we transitioning? He thought Da Vinci was an extreme mutation that showed us the potential of what we could become if we had a cross-disciplinary mind. And I feel like we need it right now. The world is changing so quickly, and there's so many technologies that are replacing what humans do, and there's jobs that we can't even imagine are gonna happen in the next decade. So it's like you have this feeling, we need to adapt quickly to flourish in this world. And so cross-disciplinary thinking is really where my father thought the clues held. And the good news is that obviously our brain has adapted for a long time, and it's because of this amazing ability called neuroplasticity. And neuroplasticity is basically your brain is always on. And every thought experience you have is either strengthening or weakening a certain part of your mind, your brain. And the white matter, I always like to think of it as that the more you do something, it's like we were talking earlier, somebody was saying it's like a muscle. The more you do it, the faster the information is going to flow. And there's a unique part of white matter, which is the connective part of your brain, called the corpus callosum. And the corpus callosum is connecting the right and left hemisphere. And neuroscientists call it the interhemispheric connection of the brain. And I like to think of it as the internet of the brain, because that's kind of the world that we're living in, where everything is getting connected. So it's like your whole brain, every aspect is being connected when you have a thought. And I actually think that's where creativity comes from, is when new ideas, some of my most creative thoughts are really when I'm daydreaming or I make an unusual connection between things that had never been connected before. And right now, my husband and I have 2 children, and there's so much focus on STEM, science, technology, engineering, math, which I'm all for. My husband's a professor of engineering, so obviously I'm for that. But not at the expense of the humanities and the arts. And I'm getting frustrated that it's so much about that conversation. So my 12-year-old daughter said it should not be STEM, it should be STEAM. And we're Jewish, so it sounds Yiddish. It's like STEAM. STEAM is what we need to be focusing on. And I just read this quote by Churchill. I already loved Churchill, but I love him more now. It said, when Churchill was asked to cut the arts funding in favor of the war effort, he simply replied, then what are we fighting for? And I feel like we need to embrace the connections. I mean, I work with neuroscientists and all the time to try to communicate their complicated ideas to reach millions and millions of people. Because the more the public understands, like this incredible forum that Glenda has provided, the more we can engage with the science. If it's stuck somewhere in a research center, it doesn't engage the public. So I think we're beginning to see the value of more integration of arts and sciences, cross-disciplinary thinking. There's this wonderful story I heard of this LA professor of art named Mary Beth, and she looked at the Ebola crisis. So I normally move around when I talk, and I'm feeling kind of stuck here, but she saw the Ebola crisis. Oh, that's not going to work. And she said, God, these people are so scared, and they're feeling lonely, and they're looking at people in these big suits that are so imposing, look like robots. What if we take a picture of them smiling and tape it to the outside of their outfit? I mean, that is what happens when you combine the arts and the sciences. And it's implemented. She went to Liberia, she implemented this program, so there's that human connection that was missing. And then this other story I love about this Argentinian mechanic who watched a YouTube video of a cork being pulled out of a bottle through a plastic bag. And he went to sleep after just watching this YouTube video, and he woke up the next day, and he thought, maybe I can help the babies that are dying in childbirth with this same trick of pulling the baby out of the womb with a plastic bag. He took it to a doctor who took it to the World Health Organization. It is now in production. And this was like cross-disciplinary thinking of someone taking an idea, taking the initiative, finding, collaborating, and then making it happen. So I would love all of you right now, I want you to close your eyes, and I want you to think of your biggest challenge. You're all wrestling with something, either personally or with work. And now I want you to think, who have you talked to about that challenge with? Now I want you to think, what is the most diverse group of people I can bring together around this problem? What would a biologist say? What would an artist say? What would a child say? What would somebody from another country say? You can open your eyes now. That was so beautiful to see you all do that. So instead of multitasking, we need to be multi-asking. We live in a world today where there is no excuse for you not to reach out to people, for you not to have knowledge and research at your fingertips. Can be done exponentially in the age of the internet. You have more access to different people and ideas than ever before. And Matt Ridley wrote this great book called The Rational Optimist, where he tracked throughout history when innovation happened. And innovation always happened, usually in cities, when there was the most people from different perspectives in the same space. And them crowding together is when innovation would happen. And it's also when empathy happens. Empathy happens when you hear a different story. So these are things that are very unique to even the most sophisticated machine. There's so much fear right now in robots and machines taking over. I think it's like ridiculous. My husband's a robotics professor, and he thinks it's ridiculous. He's like, if there's one more person that puts out an op-ed that machines are gonna take over, they're never gonna be creative. They're never gonna have empathy. They're never gonna have initiative. These are our greatest strengths to evolve as humans, is to strengthen what is unique to humans that is different than machines. We think of our brains as private, but really our brains are public. They're this communal organ that allows us to exchange ideas with people from all over the world. So if the internet is like this giant corpus callosum of the world, it's like an interface for empathy and cross-disciplinary thinking. If you think about Da Vinci, how much he could do with one brain and one notebook. And just imagine what we can do with 7 billion people online, in our own minds with cross-disciplinary thinking, across minds and across borders. So, was Da Vinci showing us a transitionary part of our species? That is the future of our species. Thank you.
Oh yeah, we gotta have a question.
Okay, yeah, okay. I finished early.
You did?
I finished early.
She gets the Golden Mike Award for finishing early.
At the Webby Awards, we instituted a 5-word acceptance speech rule, which no one has ever gone over. So I'm really into being punctual.
You're doing well. I do want to say I had the honor and pleasure of knowing Tiffany's dad and listening to him speak on his book, The Alphabet and the Goddess, and visiting with him when I visited with you in Palm Springs. Question? He was an incredible intellect and a great guy. Question? Do we have a question? Microphone? Nobody has a question about the global brain?
Wait. We have one right here. Joe's got one.
Right,
Oh.
okay. In the back and then down with Joe.
Well, I'm staff, so.
Oh, there we go. Okay.
Thank you. I had the pleasure of reading your dad Leonard's books. He's brilliant. I never had a chance to meet him, but he really was a remarkable man.
You guys would have loved each other. I mean, I was listening to you speak. I'm like, these guys would have been best friends.
Well, we would have. But a question for you. I'm impressed with the degree of creativity found in the gay population. And I guess my concern is the gays are not terribly good at reproducing themselves unless they find another biological partner. Is there any sense of saying we're missing out genetically in our culture, in our lives, in our future by not having these creative minds procreate to a next generation?
My dad goes into that a lot in Sex, Time, and Power. That book, but I live in San Francisco and they're reproducing. I'm just telling you. I mean, it's no issue. My producer's gay, they're about to have a baby, the donor, whatever. But Sex, Time, and Power, my father has all these theories about the homosexual brain and how he's got a lot of ideas about that. So, and I have Leonardo's brain here. My brother and sister and I just did a book tour where we signed on his behalf, and also that film Connected that I told you about. It ended up being all about connectedness with him and his ideas and stuff. So.
Cool.
Thank you.
Thank you. Thanks. Great. Fantastic. I mean, that probably really should have been in the creative brain, but she's just such a future thinker, we had to put her in the future brain.